Hello dear students, welcome back to our online classes. Today we are discussing 8th chapter of plus 1 physics, that is gravitation. In this chapter we are discussed about difference between gravitation and gravity. We have to understand what is gravitation and what is gravity. Then we are moving to Newton's law of gravitation. Newton is a very famous physicist and his famous law is Newton's law of gravitation. Every object in this universe attract each other. That force of attraction is directly proportional to product of their masses and inversely proportional to square of distance between them. F is equal to G m1 m2 by r square. We have to study some details about that law, and we have to consider how entrance questions are coming from that part. Here it's a new way of teaching and this is a new method. I would like to share some slides about this chapter, and I am moving to this corner and right corner. Then I can explain that slides. That is the method of this class. Okay. Now, what are the important questions in this chapter? We have to discuss 20 questions from our material. That questions are very relevant and important. Here you can see, sorry, this is not our slide. Stop share. Then I'm moving to the next slide. Yes, clear. Look at this slide. There are two bodies, M1 and M2. This is the first body, M1, and this is the second body, M2. The distance between them is R. R is the distance between them. Every object in this universe attract each other. That is Newton's law. So this body, that is first body, attract that body. Which one? M2. That force of attraction is like in this direction. Yes. So this is the F1, force due to 1. And this is F2, that is force due to second one. This body attract second body and second body attract first body. That's Newton's law of gravitation. You can see Newton's law of gravitation. This is the first body M1, this is the second body M2. The existing force of attraction, existing force is attractive force. Always gravitational force is attractive. The force is called gravitational force. So F is proportional to M1 M2. That force, which is that force between two bodies, that is directly proportional to product of their masses, that is M1 and M2, and inversely proportional to 1 by r square. This is called inverse square law. Inverse square law. A force which obey inverse square law is called central force. A force which obey inverse square law is called central force. So gravitational force is a central force. We can say gravitational force is a central force. According to Newton's law of gravitation, F is proportional to M1 M2 by r square. Everyone are familiar with this law, but that proportionality, this proportionality can be replaced by a constant G. We introduce a constant G. G is a constant of proportionality known as universal gravitational constant. What is the name of G? Universal gravitational constant. It's a very important factor, and F is equal to G m1 m2 divided by r square is the equation. What is the statement of that law? It's not important in entrance examination, but you can read that statement. Newton's law of gravitation states that everybody in this universe attracts every other body with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between their centers. The direction of the force is along the line joining of the particle. What it means, this is first body, this is second body. The line joining means line joining the centers. Okay, line joining means line joining the centers. So that is called, that is a direction. Direction is in this direction, from that in this direction. So this body is pulled by this body and this body is pulled by second body. Clear? So that is a statement, and that is the gravitational universal law of gravitation by Newton. Universal gravitational constant. We are applying a constant here. For what? For what? We are applying to replace proportionality. Yes, that is called universal gravitational constant. What is the equation? This r square comes here and m1 m2 comes here. So G is equal to fr square by m1 m2. G is equal to fr square by m1 m2. Suppose that m1 equal to m2. That means two bodies are equal. When two bodies are equal, m1 and m2 equal to 1. That means unity. Okay, r equal to 1. That's also equal to unity. But what it means? Two body having mass 1 kilogram is separated with a distance 1 meter. Then G is equal to F. Yes, because r square is 1, r is 1, m1 is 1, m2 is 1. So their product are 1. So G equal to F. So what is the definition of universal gravitational constant? It is numerically equal to force. When it is the force of attraction between masses having, bodies having unit mass. Bodies having unit mass and placed unit distance. Yes, distance must be 1 meter. Distance must be 1 meter and body having unit mass. Then universal gravitational constant is a force. SI unit of G is Newton meter square per kilogram square, and CGS unit of G is Dyne centimeter square per gram square. Newtons in CGS Dyne, meter in CGS centimeter, kilogram in CGS gram. So it's very simple. And this is the dimension of G. What is the dimension of G? M raised to minus 1, L cube T raised to minus 2. Coulomb's law of attraction and repulsion. This is a very important topic in this chapter, Coulomb's law. We have also studied about Coulomb's law in electrostatics, +2, electrostatics. Coulomb's law of attraction and repulsion here. We know that matter, property of matter is mass. Another property of matter is charge. Okay. We have to introduce Coulomb's law about terms of mass, and we have to study Coulomb's law about the terms of charge. About the terms of charge we can study it in electrostatics, and about the terms of mass, that is we are studied in this chapter. Okay, so matter has two properties, mass and charge. We are considering in this chapter property of matter, that is mass. We have a massed body, we have Coulomb's law of attraction and repulsion. Here, Coulomb's law of attraction and repulsion. But this part, the rounding part, that comes from electrostatics. F proportional to Q1, Q2, F proportional to 1 by R square, F proportional to Q1, Q2 by R square. So, Coulomb's law, in the comparison between Newton's law and Coulomb's law is F proportional to m1 m2 by r square. So F equal to G m1 m2 by r square. Coulomb's law, K q1 q2 divided by r square. That is force of electrostatic, this force of gravitation. The both are comparable, in which means here m1 m2, here q1 q2. Here is also r square, here is also r square. So Newton's law is Coulomb's law about mass. Newton's law is also a type of Coulomb's law. But here we are considering mass. There we are considering charge. That is the important. Here mass, there is charge. Here m by L, there is lambda, linear charge density. Here G, there is K, proportionality constant. Here G, proportionality constant is 1 by 4 pi epsilon 0. Its value is 9 into 10 raised to 9. We all know that. Here 4 pi g, here 1 by epsilon 0 in electrostatics. We can study that in our electrostatics. Characteristics of gravitational law. Now, we are moving to characteristics of gravitational law. The gravitational force is independent of intervening medium. Very simple. This is M1, this is F2, M2. The distance is R. If they are separated in medium air, and next they are separated in medium water, no problem. There is no problem. They are separated, whether it is separated in air, whether it is separated in water, same force existing, because they are independent of intervening medium. The force acting along the line joining of the masses, hence it is central force. I am already told that. Line joining of bodies, the force is acting line joining of bodies, in between line joining. So that is called a central force. Next one, the gravitational force is conservative force. What do you mean by conservative? Work done does not depend on path. Work not depend path. Work not depend path. It's clear. Yes. Some classification of forces are there. Central force, non-central force, conservative, non-conservative. Gravitational force is a conservative force. Also, gravitational force is a central force. Okay, it's very important. And first point, it is independent of intervening medium. Whether the bodies are in water, no problem. Whether the bodies are in air, no problem. There is a same force of attraction between them. That is called gravitational force. Number four, the force exerted by the first particle on the second is exactly equal and opposite to the force exerted by the second particle on the first. It's very simple. Earth attracting moon, also moon attracting earth. That two forces are equal. That means F1 and F2. If I am attracting you and you are attracting me, my attractive force is F1, your attracting force is F2. That F1 and F2 are equal. That is Newton's third law. Okay, Newton's third law is a very familiar law. Here is a note. We are very carefully study that note. The law of gravitation is stated for two masses. Therefore, any two arbitrary finite size bodies as shown in figure, it cannot be applied as their not unique value of separation, because here a body having mass m1, here a body having mass m2, but there is a problem. What is the problem? There has no finite size. These bodies, I am marking that bodies, these bodies has no finite shape. So we cannot apply gravitational law into that bodies, in the case of that bodies. If we want to apply gravitational law, then the bodies must have a finite shape. Look at this figure. I am marking that figure. We can apply that. We can apply gravitational law here. Why? These have finite shape. This is a finite sphere shape. So we can apply that. So it's a very important note. Next, we have to discuss vector form of Newton's law of gravitation. We are already discussed Newton's law of gravitation. What is its vector form? If we want to make a quantity into its vector form, we can multiply a unit vector with that quantity. Consider, I am moving in x direction. My displacement is 5 meters. How can I convert that 5 meters into vector quantity? 5 I cap. What do you mean by I cap? It is the unit vector in the direction of x. When I am multiplying the unit vector in the direction of x with 5, that is I cap with 5, it becomes 5 I cap. 5 I cap is representing both the magnitude and the direction of our quantity, that is displacement. My displacement is in 5 meters towards x direction. That is represented by 5 I cap. So whenever we multiply, when we are multiplying a unit vector with a quantity, it will become its vector form. Look at the slides. Here, F12 is there. What is F12? force on 1 due to 2. It is the force exerted by 2 on 1, m2 on m1, that is F12. The basic equation is G m1 m2 divided by r square, clear, but it is multiplied with a unit vector r21. What is mean by r21? It is the unit vector from A to B. It is the unit vector from A to B. R21 is the unit vector from B to A. So listen carefully. F12 means force on 1. That means M2 acting a force on 1. So unit vector is from M2 to M1. That is B to A. That is R21. This is A and this is B. A has a mass M1, B has a mass M2. Then F21, F12, for calculating F12, that means force on 1 due to 2. So unit vector is R21. R21 is unit vector from B to A. Next one, F21. What do you mean by F21? F21 is force on 2 due to 1. Force on F21 is force on 2 due to 1. So unit vector is M1 to M2. Unit vector is from M1 to M2, that is R12, this one. So unit vector from A to B. So here we are multiplying with R12 by calculating F21. By calculating F12, we are multiplied with R21. It's not very important, but there is a concept, that is F12 equal to minus F21. What it means? Both the forces are equal and opposite. That is Newton's third law. Both the forces, which are the forces? F12, force on 1 due to 2. F21, force on 2 due to 1. Both are equal and their magnitude are equal, but they are in opposite direction. Okay. Here, principle of superpositioning. Okay, principle of superposition of gravitational force. Consider a body M0. This is that body M0. There are three bodies M1, M2 and M3. These three bodies act or exert a force on M0 because M2 and M0, there is a force between M2 and M0. There is a force between M1 and M0. There is a force between M3 and M0. That means there are different forces on M0. We all know that for vector quantities, the vector quantities must be added with the help of law of vector addition. There is not just sum. We cannot add vector quantities like a scalar quantity. If force is a scalar quantity, it's very simple to add that forces. But if there are but the force is scalar quantity, not a scalar quantity, force is a vector quantity. What we'll do? We have to use equation of resultant, that is R is equal to root of A square plus B square plus 2AB cos theta. Here A is F1 and B is F2. Here also another force F3. Okay, so this that force and this one is that force and this one is that force. There are three forces. So we have to calculate net force, then F1 plus F2 plus F3. We have to add these three forces. But that addition is not scalar addition, that is vector addition. So by using vector resultant formula, we can add that forces. Okay, consider these are questions. We have to move one case. Okay, listen. This is body M1 and this is body M2. This is body M3. What is the total force on M1? That is the question. What is the total force on M1? If this distance is R, also this distance is R, then the force between these two bodies must be equal to force between these two bodies. But direction are different. Yes, direction are different. And an angle is given. The force between, sorry, the angle between these M1, M2 and M1, M3 is consider 45 degree, 45 degree. Then you should notice that the resultant force is root of, here there will be a force between M2 and M1, and here will be a force between M1 and M3. Both are F because of equal distance. They are separated with equal distance. So both forces are said to be F. So F square plus 2F cos theta. Here theta is 45. What is cos 45? 1 by root 2. If we have to calculate this square root term, I'm writing here root of f square plus f square 2f square plus 2f of cos theta means 2f square into 1 by root 2. It's very clear. Okay, so 2f square can be taken outside, root of 2f square taken outside, so 1 plus 1 by root 2 is in bracket, f square taken outside, that is f into root 2 into 1 plus 1 by root 2. What is 1 plus 1 by root 2? It's very simple. Cross it. 1 into root 2 plus 1 by root 2. So 1 into root 2 by 1 plus root 2. Okay. 2 root 2 divided by 1 plus root 2 f. That is the answer. F into root of 2 root 2 divided by 1 plus root 2. This is the answer. So we have to calculate the vector addition. That is principle of superposition. Principle of superposition is important for board examination, but it's not very much important for entrance examination. Just you have an idea that forces can be added. Force is vector quantity, so that addition is vector addition. So this body acting, this body and my hand, this pen and my hand, there is a gravitational force, and this pen and this computer, there is a gravitational force. The net gravitational force is the sum of these two forces. Net force on this pen is force due to my hand plus force due to computer. Clear? That is vector addition. So we have to use vector algebraic equation. The resultant of two vectors is r is equal to root of a square plus b square plus 2ab cos theta. That by concept of parallelogram law. Okay. Next, we have to move acceleration due to gravity. It's a very simple concept. Acceleration due to gravity. Acceleration due to gravity can be represented as small letter g. We all know that weight is equal to mg. It's a very simple equation. W equal to mg. But here that g is called acceleration due to gravity. Consider an apple falling freely to the ground, or I am falling freely to the ground. That means body acting downward. That is mg. Okay. What is mg? Weight. That g is 9.81 meter per second square. That is acceleration due to gravity. Consider Earth. Earth means our planet. All planet have acceleration due to gravity. G is representing GE, acceleration due to gravity of Earth. Acceleration due to gravity of Mars, yeah. Acceleration due to gravity of Neptune, yeah. There are acceleration due to gravity for all planet. So F is equal to m by r square. That is force equation. Yeah. F equal to ma. A equal to F by m. Oh, A equal to F by m. What is F? G capital letter M small letter m divided by r square divided by m. This is mass of body and this is also mass of body. So this get cancelled. This is capital letter M. That is mean by mass of Earth. So Earth attracting me. I am the body. My body mass is m and Earth mass is capital letter M. The acceleration due to gravity for me is capital letter G, capital letter M divided by distance from center of Earth to body. R is the distance from center of Earth to body. So G is equal to Gm by R square. Okay. So G is equal to Gm by R square is a very, very, very important equation in this chapter. Okay. Next one, acceleration due to gravity on surface of Earth. Acceleration due to gravity on surface of Earth. On the surface of Earth, we know that G equal to Gm by R square. Yeah, small letter R square. Here, small letter R is equal to capital letter R. Why? Small letter R is equal to capital letter R. Why? Body at the surface. So Gm by small letter R instead of that capital letter R. So Gm by R square is the equation. Look at this equation. It's clear. So if G is acceleration due to gravity on the surface of Earth, then weight is equal to mg. There is a simple mistake in the slide, so not watching that though. So there is gravitational force acting toward the center of the Earth. Yes, always gravity is acting towards center of the Earth. When I am falling freely, Earth pulls me to its center. That is why I am falling freely. Okay, acceleration due to gravity on the surface of Earth, G equal to Gm by R square. What is its value? The small capital letter G equal to 6.67 into 10 raised to 11. Its value 6.67 into 10 raised to minus 11. Don't forget it, it's minus 11. Capital letter M, mass of Earth. Mass of Earth can be calculated as 6 into 10 raised to 24. Listen, density equal to mass by volume. So mass is equal to density into volume. So density into volume means density into 4 by 3 pi r cube. Yeah, 4 by 3 pi r cube. What it means? Density into volume gives mass. That mass is 6 into 10 raised to 24. Okay. We cannot weigh Earth, but we can calculate the weight of Earth. That is 6 into 10 raised to 24. That is mass of Earth. Into G, that is weight of Earth. Okay. So mass of Earth is 6 into 10 raised to 24 kilogram. Radius is equal to 64 into 10 raised to 5 meter. Then we get G equal to 9.8 meter per second square. It's a very, very, very familiar value. G equal to 9.8 meter per second square. Ready? Then variation in acceleration due to gravity. Acceleration due to gravity can be varied due to number 1, height. Consider I'm a height h from the surface of Earth. When I'm moving upward, my height increases, so acceleration due to gravity will change. Number 2, when I am penetrating to the Earth, I am making I am digging the Earth, so I'm moving into the center of Earth. Acceleration due to gravity will vary. So next point is depth. We have to analyze these 2 points. And next third one, shape of Earth. What is the shape of Earth? It's called a geoid. But nowadays, modern physicists finds that Earth has no shape. But on the base of textbook, you must study that shape of Earth is geoid. Due to shape of Earth, acceleration due to gravity can be varied. We have to discuss it that because at the poles, distance to the poles is r, and distance to the equator is r. R is must be less than r. Distance to the pole is very less compared to distance to equator. This is equator and this is pole. Distance to pole is very much lesser and distance to equator is very much greater. So due to that distance change, there is a value change in acceleration due to gravity. Number 4, the number 4 is rotation of Earth. Rotation of Earth. Earth is rotated. There is 2 types of rotation. First one, revolution, that is around the sun. It takes 365 days. But without revolution, Earth has another type of motion, that is rotation. Rotation, its own axis, it takes 24 hours. Due to this rotation, Earth acceleration due to gravity value will change. All other planets have acceleration due to gravity. Okay, we have such a type of questions, that is Jupiter, Neptune, Uranus, Mars, Saturn. All planets have its acceleration due to gravity. Okay, next one, there are 4 factors. Then first one, variation with altitude, that means height. Variation with altitude, that means height. Listen, altitude. Consider a body of mass m like this. at a height h, and we have to calculate the acceleration due to gravity at that point. Okay, at the surface of Earth, we have already known that gm by r square. Then it is very simple, gm by r plus h the whole square. Why? But why? H height, the body placed at h height above the radius. Actually, this is small letter r square. When capital letter r square comes when at the surface, body at surface, but now body not at the surface, it at a height h. So very simple, r plus h the whole square. Listen, gm is equal to g is equal to gm by r plus h the whole square. You know that g is equal to gm by r square at the surface. You know it, yes. Then what is gm? It is gr square. It's very clear. Gm is equal to gr square. So we can substitute gm by gr square. So g height, acceleration due to gravity due to height, can be calculated gr square by r plus h the whole square. Very good. R square and r plus h the whole square. We can calculate this term. This is r square. This is r plus h the whole square. So joining these two terms like this, r by r plus h the whole square, r by r plus h the whole square. So g is equal to g into, listen, r by r plus h the whole square. So that is variation of height due to variation of acceleration due to gravity due to height. Listen, this is our final equation. Now there is another type of simplification, that is 1 by r plus h divided by r the whole square. What is doing here? Take r by r, r by r, r by r. That is like r by r is 1, r by r is 1, and h by r the whole square. R by r 1, so 1 square 1. So in numerator only 1 remains. 1 by 1 plus h by r the whole square. Expanding 1 by 1 plus 1 h by r the whole square. 1 plus h by r the whole square is in denominator now. It comes forward, upward. So 1 plus h by r the whole raised to minus 2. Yeah. 1 minus 2h by r plus h by r the whole square. Neglecting higher power. What do you mean higher power? H by r, 2h by r, 3h by r. So neglecting higher powers, square, cube, fourth power, all powers are neglecting. Then this term only remain. 1 minus 2h by r remain. So gh is equal to, the final equation I am writing here, gh is equal to g into 1 minus 2h by r. It's very, 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 very important. This is an equation. Also this one is equation, because when height is given, we have calculate gh, acceleration due to gravity due to height. Only height is given, no matter, no problem. We can calculate acceleration due to gravity. Why? Because I have equation gh is equal to g into 1 minus 2h by r. Look at dear students, h is given, r is known, g is known, then gh can be calculated. Very simple. So this is a very, very important topic. And next one, variation due to depth. I am already told that acceleration due to gravity can be varied by 4 factors. Number 1, shape. Number 1, attitude. It's over. Number 2, depth. Yes, basic equation is gm by r square, and g is equal to g into 4 by 3 pi r cube rho. I am already told this. Density into volume is mass. I am substituting that term. Okay, then g is getting 4 by 3 pi g r rho, because this r square and r cube get cancelled, only r remains, 4 by 3 g and pi r rho. That is equation number 1. M is equal to, from here, mass is equal to 4 by 3 pi r cube rho. That is, I am substituting here then, and I get equation number 1. G dash, what do you mean by G dash? First body is here, next it's move and move it B. Then this is the sphere, this is the sphere. So I have to calculate acceleration due to gravity. I have to calculate acceleration due to gravity at this depth. So G dash, or it can be denoted as GD. Earlier we are denoting like GH, here GD. g m dash by r minus d the whole square, because r is now r minus d, because this length is subtracted, so r minus d the whole square. This is m dash. What is m dash? M dash is density into volume, but m dash is density into what is volume? 4 by 3 pi r minus d the whole cube. So I am substituting that here. That is the step. G dash is equal to g into 4 by 3 into pi into r minus d the whole cube into rho. That is density into volume. That is mass by r minus d the whole square. Listen carefully. G dash is equal to 4 by 3 into pi g r minus d rho. R minus d the whole square, and this cube can be neglected, cut it, and 4 by 3 into pi g into r minus d into rho. This is equation number 2, this is equation number 1. So we have to find out g dash 2 by 1. Equation 1, this is 1, this is 2. Equation g 2 divided by 1, 2 divided by 1. So g dash by g equal to this term, 4 by 3 get cancelled, pi get cancelled, g get cancelled. Finally r minus d by r is remain. G dash by g equal to r minus d by r is remain. Okay, what is r by r? R by r is 1, then d by r remains. This is the equation. So I am writing equation here. G dash is equal to g into 1 minus d by r. Look at the equation. Only depth is given. We can calculate the variation in acceleration due to gravity. G is known, r is known, d is 20 meter or 30 meter. Then put that value as d. Calculate the question. It's a very, very simple topic. And g dash is equal to g into 1 minus d by r, and g equal to r minus d by r. G is equal to r minus d by r. This is very, very, very relevant equation and very simple equation. Okay, you must notice that equation 1 minus d by r. Okay, 1 minus d by r or r minus d by r. Okay, it's very clear. G dash is equal to r minus d by r. This is not wanted. This equation is not necessary. Okay, this equation is not necessary. Okay, listen. Variation of acceleration due to gravity with height, like this is the equation. Variation of acceleration due to gravity with the depth, this is the equation. Look at that equation. This is gh, this is gd. Okay, acceleration due to gravity can be varied with the height, like g into 1 minus 2h by r. Acceleration due to gravity varied equation like gd equal to g into 1 minus d by r. It's very, very simple, and also it's very complicated. Variation due to shape of earth. What is the shape of earth? Shape of earth is geoid. This is rp. Rp always less than re. What is re? Distance from center of earth to equator. What is rp? Distance from center of earth to pole. Clear? Distance from center of earth to equator is re. Distance from center of earth to pole is rp. Rp is less than re. What it means? Ge, equator, acceleration due to gravity at equator is gm by re square. Acceleration due to gravity at the pole gp equal to gm by rp square. We know that re is greater than rp. That means denominator is higher. This is lesser. Here denominator is lesser. This is higher. So we can say that acceleration due to gravity at the pole is very much greater than acceleration due to gravity at equator. Why? Radius comes in denominator. Radius comes in denominator. What it means? Denominator for equator is greater. Denominator for pole is lesser. When denominator become lesser, value become greater. When denominator become greater, value become lesser. Clear? So Ge is greater than, Gp is greater than Ge. That is the variation of acceleration to gravity with height. This marked section, please note this marked section. Listen. Therefore, the weight of the body increases as it is taken from equator to pole. When I am taking a body from equator to pole, its weight increases. Weight increases, not mass. Mass is a constant quantity. Weight increases. Why? But why? Mass is a constant quantity, but weight can be changed because equation of weight is mg. At equator, W equal to mge. At a pole W equal to mgp, GE or GP, which is greater? GE? No, GP. GP is greater. So weight at equator, this is weight at a pole. Weight at equator is lesser, weight at a pole is greater. Look at that denominator, equation's denominator, that is gm by r square. Calculate this r at pole and at equator. We can have an idea, we get an idea about the acceleration due to gravity change at equator. And the final fourth point, variation due to shape of earth. Sorry, third point, it is clear. Variation due to shape of earth is clear. We have to notice another point, that is, I am writing here number, this is not number 4, this is number 3, shape. Number 4, rotation of earth. Rotation. Due to rotation of earth, acceleration due to gravity changes. It is equation, look at the screen, gr is equal to g minus r omega square cos square lambda. This is the equation. This is important for IIT and JE examinations because this is a very complicated equation. Gr is equal to g minus r omega square cos square lambda. Consider lambda, latitude of plane. Lambda is 0 at the equator. Lambda is 90 at the poles. When lambda is 90, what is cos 90? Cos 90 is 0. Okay. At the equator, lambda is 0. At the poles, lambda is 90. Cos square 90. So at the poles, cos 90 is 0. So this term is 0. At the pole, listen, at the pole, lambda is 90. So gr is equal to g. So rotation of earth has no effect at the poles. Acceleration due to gravity does not vary. Acceleration due to gravity does not vary due to rotation of earth at the poles because here lambda is 90. But there is affection of acceleration due to gravity at equator because there is lambda is 0. When lambda is 0, what is gr? G minus r omega square is equation. The basic equation is gr is equal to g minus r omega square cos square lambda, and the term cos square lambda is 0 at the poles and cos square lambda is maximum at the equator. So acceleration due to gravity is varied with the rotation of earth at the equator, not at the poles. So very important topic, very important point to be noted, that is acceleration due to gravity changes due to rotation of earth at equator, not at poles. Okay. Next, we have to discuss about the gravitational field. This is a very important topic. Also, this we are studied in electrostatics. There, we are studied about electric field, but here we are studied about gravitational field. Clearly, gravitational field concept is arising from gravitational force F is equal to G m1 m2 by r square. We are already discussed about that. What is mean by a gravitational field? It's very simple topic and everybody know that. Gravitational field means where the gravitational force experiences. Gravitational field means where the gravitational force experiences. Consider this is a body of mass m. I am placing another body of mass small letter m here. It experiences an attractive force towards this capital letter M. But when I am placing that body here, there is no force on this body due to this body. Okay, then we can say that this is the gravitational field of capital letter M. I am placing small letter m outside that body, outside that gravitational field. Okay, outside that gravitational field. That is meant by gravitational field. Then what is intensity? Intensity of gravitational field at any point in a gravitational field is defined as the force acting on unit mass placed at that point. Consider this is mass m. m0 is placed at this point. There is a force experiencing towards capital letter M. Okay, because this M0 is placed at the gravitational field of capital letter M. How much force experienced by M0? That is F. Then what is gravitational field intensity G? Vector G, or gravitational field intensity EG. EG equal to Fg divided by M0. For M0, there is Fg force. So for unit mass body, for unit mass, that can be calculated by dividing M0. For M0, there is a force of Fg. Okay. M0, for M0, there is a force of Fg. For unit mass, how many force? Fg by M0. That is Eg. It's a very complicated concept, but that's have no numerical aspect, so we can leave it. So here gravitational field F is equal to G m1 m2 divided by r square. Gravitational field has a range. What it means, at r equal to infinity, force is zero. There is no force. When distance increases more than a limit of distance, there is no force. That means there is no gravitational field. Also, there is no gravitational field intensity. All are zero. This range or region around M1, where the mass M2 experiences gravitational force, is called gravitational field. Hey, this is body of mass M1 Earth. If M2 got experience, if M2 experiencing a force, then it is in gravitational field. Or it cannot experience any force, then it's not in gravitational field. So I am already discussed about this topic, gravitational intensity. What is the equation? Eg equal to, look at my writing, Eg equal to G m1 m2 by r square divided by, let it know, we are introducing a new mass m0. Here I am taking that mass as m2. I am placing m1 at its place, that is the parent mass, and I am taking m2 to that get field of m1. So for unit mass, how can I calculate for unit mass force? Can divide with m2. M2 get cancelled. So equation is Gm1 by r square. Okay. In the case of this figure, look at this figure. What it means, there is a capital letter M. So there is a force is equal to G M and small letter M0 divided by r square. This is for M0 mass. What for unit mass? Divided by M0. Very simple. So M0 get cancelled. So this equation is given. Eg, gravitational field intensity, is Gm by r square. The gravitational intensity at any point in a gravitational field is defined as the force acting on a unit mass, not on M0. Force acting not on M0, any mass, not on any mass. Not on any mass. It is force acting on a unit mass. Force acting on a unit mass. So it is also called as strength of gravitational field. Gravitational field intensity is also known as strength of gravitational field. In vector form is nothing but multiplied with a unit vector. Multiply with a unit vector. Then our equation is into the vector form. Okay. This is very simple. F by M is Eg. Yes. For M, there is a force. For M, there is a force. What is for unit mass? Divided with that M, then we get unit mass force. Okay. Dimension is clear here, because force dimension is mLt raised to minus 2 divided by mass. So answer is m0 L raised to 1 T raised to minus 2, put in the bracket. Next, we have to discuss on gravitational field strength of different objects. In electrostatics, plus 2 electrostatics, we have studied about different object, electrostatic force acting on different object, that is electric field strength on different object. Plane sheet, solid sphere, hollow sphere, metal sheet, infinite long straight conductor. Like that, here we can also study the gravitational field strength on different object. I am discussing about the solid sphere here. What is mean by solid sphere? Shot put ball, it's a solid sphere. If its radius is capital letter R, but I am considering a point P. A point P. It is R distance from the center of the solid sphere. Then electric field strength is defined as the Eg equal to Gm by R square. Electric field is not. Gravitational field strength outside the spherical shell is Gm by R square towards the solid sphere center. Yes, it's clear because this is the parent body, solid sphere. Parent body attract this body towards its center, Okay, it's a very common concept. At the surface, Eg equal to Gm by R square, symbol. At the surface, okay, capital letter R. Why? Because this is the radius. Okay, and next one, at the center of the solid sphere, what is gravitational field strength? 0, because here R is 0, center R is 0, radius is 0. So gravitational field strength can be calculated. How much force experienced by a body placed at that point? At point P, a unit mass is placed. How much force it can experience? That is the gravitational field strength at that point. It's very simple. At any object, at any shape, we can apply that concept. Consider a unit mass is placed at that point. How much force is experienced by that unit mass? That is the gravitational field strength. Okay. Gravitational field strength, we are already discussed about it. And gravitational potential energy. What is meant by potential energy? Consider a body of mass m. I am lifted it towards a height h. Then I am doing a work called Fs. What is F? M and S. Here, upward downward motion, acceleration is acceleration due to gravity, and the displacement is h. So work done is mgh. That work done is stored as potential energy inside the body. Okay, that work done is stored as potential energy inside the body. When it is here, its potential energy is 0. But at the height h, its potential energy is mgh. Why? Mgh work is done on that body. Mgh work is done on that body. That mgh work is stored as potential energy. UB minus UA equal to minus field A to B. UB minus UA, W of external A to B. These are the two equations. I can explain. Ready? Consider this is point A and this is point B. What is UB minus UA? When a body moves from A to B by doing an external work. Okay, body move from A to B. So work is turned to as potential energy. Work is changed as potential energy. So B at a higher potential, UB. A at lower potential because starts from A, we are starts from A. So UB minus UA. UB minus UA means how much work is done on that body from A to B. That is this W. Okay. Then what is minus? Actually, from B to A work is calculated. Okay, from B to A work is calculated. It is a negative of work A to B. So we get the work B to A. Negative of work A to B is the answer. So we get a negative. Then UB minus UA, work external to A to B. But a work field A to B. Both are different cases. But is simply, I'm talking simply, just understand, there is two type of work because first one is work done by field and next one is work done by external force. Consider this is A, this is B. I am moving a body from A to B. I am doing work on that body. That is positive work. From A to B, that is positive work. Here, the whole work is converted into potential energy at B. So here potential energy is UB, here potential energy is UA. Which one is greater? UB is greater than UA. It's very simple common sense. So because from A to B, I am done working on that body and it reaches UB. So UB minus UA is a positive quantity. UB is greater than UA. What is UB minus UA? What is the equation? I'm saying that it is work external from A to B. How much work I am doing from A to B, that work is stored as potential energy. Okay, then what it means? Already there is a potential energy at A and finally at potential energy at B. The difference is calculating, which means we get an idea about how much potential energy is gained now. That gained potential energy is due to work done from A to B. Okay, so UB minus UA is work external. Then what is first equation? Why a minus comes? Here, not work external. This is work of field. Field is always against this motion. Okay, external force. That external force, field force is always external to opposite to external force. That means from A to B, field is working from B to A. So we have put a minus. Both the equation are same. You just understand this equation, second one. That's very important. UB minus UA is work external A to B. What it means, from A to B, I am doing work on that body. It reaches at B. That means that work done is changes into potential energy. Already it has a potential energy at A. Now it has a potential energy at B. The difference is calculated. So how much potential energy is gained, that is obtained. Okay. That potential energy comes from the work of, from where to where? A to B. The work external of A to B is converted to potential energy. So we can calculate a change in potential energy by calculating work. That is the very, very important point. Okay. Gravitational potential energy of a system of particle. Gravitational potential energy is a scalar quantity. Okay. Then this is M1, this is M2, this is M3. There is a gravitational potential energy U12 between this one. This is change in potential energy from 1 to 2. This is change in potential energy from 2 to 3. This is change in potential energy from 3 to 1. Okay, so this body is moving like this. A body is moving like this. So total potential energy can be calculated U31, U21, U23. This is scalar quantity. Just add these things. Just add these things. Clear? Look at this question. Where the net gravitational field at between two bodies is 0. Gravitational field between two bodies is 0. Where? Consider this is that body. This is that body, first one. And this is the second body. Mass is capital letter M and radius is capital letter R. Here mass is 16 m and the radius is 2r. Here, where the gravitational field at P will be 0. Net gravitational field at P will be 0. Consider a point P here. Okay, this is the point P. When this body of mass small letter m moves with a velocity u, when it reaches P, there is velocity is 0. Why? There is no force there is no force acting on that small letter m. That is the answer. Why? This body small letter m moves with a velocity u because of the force experiencing from this body and this body. From both bodies, it experiencing force. But at point P, we are assuming that it is 0. What it means? What it means? There is no force experiencing on M due to these 16m and small letter m. There is no force at P. That means there are Eg1 and Eg2 are same. What it means? Gravitational field intensity at both points are same, because this body attracting this body towards this and this is attracting towards this direction. So it is at 0. What it means? The attraction by this body and attraction by this body, second body and first body are same. What it means attraction is same? Their intensities are same that point. At that point, their gravitational intensities are same. So consider this distance is as x. Total is 10. Then this is 10 minus x. Okay, this is 10 minus x. So I thought not 10 r. So this is x, then 10 r minus x. 10 r minus x, remaining part. This is x, this is 10 r minus x. Consider g equal to, here mass is 16m by x square. Here gm by 10 r minus x the whole square. Calculating this, g and gr get cancelled, m get cancelled, x square. 10 r minus x square is taken in and x square is there. 16 is taken downward of that second part. 1 by 16. Calculating 10 r by x minus 1 equal to 1 by 4. Then 10 r by x is equal to 5 by 4. 10 give it 2 and 5 and 10 get cut. Then this is get 2. 2r is equal to 4 into 2r, 8r is equal to x. So this x is equal to 8r. 8r. So what is the meaning of this question? In this question, there is a point where the gravitational field intensity is 0 in between two bodies. Yes. Why? The equal force experienced or exerted by that two bodies on another body of small letter m. How can we calculate it? I'm showing that can be calculated by these steps, and x is equal to 8r now. Okay. Gravitational potential. We are already discussed about this gravitational potential. It is defined as the amount of work done also. Gravitational potential energy is also amount of work done, but there is a slight difference. There is a slight difference from point A to point B. That is change in potential energy. That is change in potential energy. But here, body is brings from infinity to that point. I want to know what is the gravitational potential at this point P. I'm just bring a unit mass from infinity to that point. How much work is done for that? For what? For bring that unit mass body to point P. How much work is done for that? That is the gravitational potential. So gravitational potential is defined as the work done by the external agent in bringing the body unit mass slowly from infinity to that point. Okay. Gravitational potential V equal to U by M. Okay. U by M, because it's moving from infinity to that point. Unit mass, work done for unit mass to be calculated, but here work done for small letter m is get. So we can divide it by m, we get work done for unit mass. Work done for unit mass. V equal to minus gm by r. V equal to minus gm by r. It is a scalar quantity. SI unit of potential is joule per kilogram, because this is joule and this is kilogram, then SI unit is joule per kilogram. CGS unit is erg per centimeter. U equal to minus gmm by r. Then V equal to minus gmm divided by r, minus gm by r. This m is not required. For bringing unit mass, that is gravitational potential. I'm already told about that. But for bringing a mass of m, a body has mass m, that is gravitational potential energy for m mass. For unit mass, it is gravitational potential. Okay. Gravitational potential at any point in gravitational field is defined as the work done to bring unit mass from infinity to that point. I am bringing a unit mass from infinity to that point. So in equation, there is no small letter m, because we have to divide it with m. So m and this m get cancelled. So V equal to minus gm by r. This minus arising from derivation. Okay. For we are preparing for entrance examination though. So derivation is not important. What in which path this equation is get, that is not important. The only important thing is equation. Minus gm by r is the equation. U equal to minus gmm by r. U, but V potential, gravitational potential is V, gravitational potential energy is U. Then V equal to minus gm by r, U equal to minus gmm by r. I am repeatedly saying V equal to minus G capital letter M by R, but U potential energy minus G capital letter M small letter m divided by R. We are analyzing that gravitational potential energy due to a sphere. Here we are analyzing gravitational potential due to a sphere. Gravitational potential due to a sphere. That sphere is maybe hollow or solid. Okay. Consider this is a hollow sphere inside a cavity. That inside a cavity of sphere. That is sphere is called hollow sphere. At R is equal to R. That means at surface. Yeah. R is equal to R means at surface. At a surface minus Gm by R the equation. Yes, the general equation is minus G capital letter M divided by small letter r. But here R equal to R, then minus Gm by R the equation. This is a derivational part. This is not important. This is derivational part. But this is very important. V out is minus Gm by R. Yeah, we are already told about that. Potential is minus Gm by R. But at the surface, there is a small change. At the surface, R is equal to R. So equation changes like this. Okay, so gravitational field potential due to hollow sphere, gravitational potential due to solid sphere. That is also an important topic, but it's a very complicated, very complicated calculations and integrational part that is not understandable in crash courses. It is we are discussing repeating batches, so I am skipping that topic. I am moving to variation of field density for solid sphere. Please just memorize this equation. Okay, just memorize. You can simply solve questions. Okay, just memorize the equation. Consider a solid sphere of mass m and R be the radius of the solid sphere. Okay, consider a point P, a field of solid sphere is. This is P. It is at the field of solid sphere. E outside is minus Gm by R square, symbol. If we consider the graph of field E with the distance R, graph field E with the distance R, this is that graph, consider like this. This is gravitational field intensity, and this is R. The shape of graph is first a straight line, then a parabolic. Because at the surface minus Gm by R square is the gravitational field intensity due to solid sphere. Minus Gm by R square. Inside the solid sphere there is derivation, but I am not saying derivation. You must memorize inside the solid sphere E equal to minus G capital letter M small letter R divided by R cube. But listen, at outside and the surface there is R square at denominator, but inside there is R cube. Okay, there is R cube minus GMR by R cube. It's a very important three relations. This graph is not much important. This three equation is very important. Okay, next one, we have to solve gravitational variation of gravitational field for a uniform thin spherical shell. What it means, there is solid sphere and this is thin spherical shell. For thin spherical shell, field at P, that is point outside, minus Gm by R square, no problem. As we towards the hollow sphere, that means penetrating towards the hollow sphere, it is minus Gm by A square. What is mean by A? A be the radius of the hollow sphere. A be the radius of the hollow sphere. So inside this sphere there is intensity 0 because this is hollow sphere, spherical shell. Okay, spherical shell means inside a cavity there is no mass, so there is no attraction, so there is gravitational field intensity is 0. So there is a slight difference with the solid sphere. At the solid sphere, R square, and R cube. But here, R square, A square, and inside is 0. In solid sphere, inside is proportional to R cube. Here, there is no field inside. That is the main difference. Okay. Next, we are moving to very important topic in this chapter, that is orbital speed, time period, total energy and binding energy of satellite. What is satellite? We are all know what is satellite. INSAT, Aryabhatta. There are many more important satellite names that asking for exams, for PSC exams. But here we have to study the physics of satellite, working of satellite, and what are the concept of satellite. First, we have to look what is orbital velocity. We have to look what is orbital velocity. That is orbital speed. Orbital velocity, the satellite is launched from the surface with the help of a rocket. A satellite is launching with the help of a rocket. Which part it in particular orbit with a tangential speed appropriate for that orbit? We have to put that satellite in an orbit for revolving around our planet. For that, at what velocity we should project that satellite, that is called orbital velocity, orbital or orbital speed. Okay, then orbital speed, since satellite is orbiting along a circular path. In chapter number 3, motion along a plane, we are discussed about a circular path. There is a requirement for the provision of centripetal force, which is always directed toward the center of the orbit. If I am the planet, I am projecting a satellite, but that satellite has a centripetal force towards my center, because from here I am projecting that satellite, and that satellite moving in circular path. Circular path means there is centripetal acceleration and centripetal force. We must overcome that centripetal force. Otherwise, it is directly moving towards my center and hit and collapse. It does not happen. Why? We are putting an orbital velocity for that satellite. Its equation is V0 equal to root gm by r. V0 equal to root gm by r. For entrance purpose, just memorize the equation, but please understand the concept. This velocity is the velocity to overcome. For what? Overcome centripetal force. Okay. Then, if satellite is revolving at a height h above the surface of Earth, satellite is revolving at a height h, generally we equal to root gm by r. Okay, root gm by r, sorry, small letter r, root gm by r. Gm is equal to gr square. Everybody know it. Gm is equal to gr square. So we equal to root gr square divided by r. Gr square divided by r. What it means? And this r is given. What is r? R is equal to radius plus at a height. That is total r. Put that value here. R plus h. This is the equation. I am writing here. V equal to root of gr square divided by r plus h. Put this r square outside, then it will become r. That is this equation. Just read this equation. V equal to r into root g by r plus h. V equal to V0 equal to r into root g by r plus h. So dear students, there is so many equations for orbital velocity. V0 root gm by r is the general equation. And if r is equal to r plus h, we can write it as V0 equal to root gm by r plus h. And we know that g equal to gm by r square and gm is equal to gr square. Put that value here. Then we get to V0 equal to root gr square by r plus h. That r square taken outside, we get to V0 equal to r into root of g by r plus h. These are important equations for orbital velocity. Then what is the time period of satellite? Time period means time taken by the satellite for completing one revolution. Time taken by the satellite for completing one revolution. How we can calculate that? Circumference of orbit divided by velocity. We know that velocity equal to displacement by time. But time, we want to calculate time, displacement by velocity. What is displacement? Circumference of orbit. What is velocity? In which velocity Satellite is revolving in orbital velocity. So put that orbital velocity under denominator. Okay. Period is circumference or orbit by orbital speed. Then we have to calculate the circumference of orbit. It's simply 2 pi r. Why? From center at an r distance it is revolving. So it is 2 pi r. That is that circle. Divided by root gm by r, which is orbital velocity. This is the basic equation. You must study that equation. These all are another case of equations. Okay. If this 2 pi is taken outside, so 2 pi into root r cube by gm. It's also right because from when r cube, r square is taken outside. R square taken outside, it is r. And root r by gm is inverted. It is get at the denominator root gm by r. This and this equation are very same, but this r is taken into the root. So it is become r cube. When it is become into the root, it is r square. And also this r square, this gm by r also an r, that will become r cube. This equation is also noticeable. V0 equal to root gm by r. This very familiar equation. So t square is equal to 4 pi square r cube by gm. That is squaring this equation. T square, 2 pi square means 4 pi square, r cube, root r cube square, then r cube by root gm square gm. That means t square proportional to r cube. Time period is directly proportional to third cube of or cube of radius. Okay, cube power of radius, third power of radius. Time period square is directly proportional to third power of radius. From here, optional question, ratio questions are given. Ratio questions are also asked from here. What it is? Given a t1, another given a t2, and radius r1 is given. What is r2? Like, put the values in this equation. From here, t1 by t2 all square is equal to r1 by r2 whole cube. Okay, make equation from here, and it's a very important topic. That is, time period is directly proportional to, time period square is directly proportional to r cube. This is very important topic, and time period is equal to 2 pi r divided by root gm by r. Root gm by r. This root gm by r taken into numerator, it become t equal to root r by gm, and there is another 2 pi r already in denominator. This r is taken inside. T equal to 2 pi into root r cube by gm. This is also important equation. I have already discussed it. Okay. Formulas. T equal to 2 pi root r cube by gm is an important formula. T equal to 2 pi root r plus h the whole cube by gm. At a height h, r is become r plus h. Close to the surface, r is become r. Time period of in terms of acceleration due to gravity, 2 pi root r by g. Okay, because gm by r is g. Just notice this equation. At a height, r plus h. Then g become gh. We are also studied about acceleration due to gravity, variation with the height. Put that value here. And r is become r plus h. Close to surface, 2 pi into root r by g. Close to the surface, g is also g, and r plus h is not given. H is not needed. Only put r at the surface, close to the surface. These 6 equations are very important. Pause the video and note down it. Okay, you can solve every entrance question from this part by using this equation. Okay. And next one, total energy and binding energy of satellite. Potential and kinetic energy of satellite. These also discussed in work energy power, in entrance part of work energy power. But I am also discussed here, energy of a satellite. Energy of a satellite. The potential energy of satellite is minus gmm by r. This is mass of planet. This is mass of satellite. But how we can calculate the kinetic energy? Kinetic energy is half mv square. Potential energy equation is minus gmm by r. Okay. M is planet, capital letter M is planet, because satellite is revolving around that planet. Small letter m is mass of planet. Simple. Kinetic energy is calculated by using half mv square. What is half mv square? Half m into v0 square. Why v0? It is the velocity of satellite. We have the equation of v0 root gm by r. Square it. So root is neglected. Root is cut. So half into m into gm by r. M, so kinetic energy is gmm by 2r. Very simple. Gmm by 2r. So equations are U equal to minus G capital letter M small letter m by r, which is this capital letter planet mass, because satellite is revolving around that planet. Small letter m, that is satellite mass. R is the distance from center of the planet to the satellite. Kinetic energy is gmm by 2r. I am discussed the detail. Okay. The potential energy of satellite equation is given. Kinetic energy equation is given. Total mechanical energy. What is total mechanical energy? Kinetic energy plus potential energy. Add these two terms. Add these two terms. Put here a 2 and here also a 2. 2 by 2 is 1. So we can add it like this. And add this. 2r common. 2r is common. Minus gmm by r plus gmm by r. Answer is minus gmm by r. Minus gmm by r plus gmm. Sorry, minus 2 gmm plus gmm. What? Minus 2 gmm. This one. Plus gmm. The answer is minus gmm. So, and total energy. What is total energy? There is a minus and G. Capital letter M, small letter m divided by 2r. Which is this equation? Kinetic energy gmm by 2r. What is total energy? gmm by 2r, but there is a minus. So I can say that total energy equal to minus of kinetic energy. Wow. Total energy equal to minus of kinetic energy. Listen, dear students, we are already find what is potential energy and we are find what is kinetic energy. Just notice the equations. Sum of these two. How we can sum of? Put it to here and put it to here. So denominator are same. Add together, we get minus gmm by 2r. Okay. Okay. Binding energy of a satellite. That's a very important topic we have to discuss. Okay. Binding energy of a satellite. First one, the minimum binding energy, the minimum energy which must be supplied to satellite so that it can escape from the Earth gravitational field is called the binding energy of the satellite. Earth has a gravitational field. Ready? We are sending a satellite from Earth. So satellite must can break the Earth gravitational field and reach its orbit. So we must provide an energy. We must provide an energy. For what? For what? For escaping from Earth gravitational field. That energy is called binding energy. There is a binding energy. We can supply energy greater than or equal to binding energy to escape satellite from Earth's field. Satellite is not at Earth's field, it's outside the field. We have to send it outside the field. Outside the field is called an orbit. How we can send that satellite to that orbit? Just to give an energy equal to binding energy. It's very good whether it is equal or greater than binding energy. So binding energy equal to total energy. Then only it can escape. Binding energy equal to what is total energy? We have studied that minus gmm divided by 2r. 2r. Okay. gmm divided by 2r. Ready? There is minus also and here also minus. Then minus minus plus. What is the equation? gmm by 2r. Binding energy gmm by 2r. What it means? We have to oppose total energy to send a satellite. Just one word. We have to oppose total energy to send a satellite. That's it. That's it. Next one, escape velocity. What do you mean by escape velocity? Escape velocity is the minimum speed with which a body must be projected from the surface of the planet to that permanently overcome and escape from the gravitational field of the planet. while we are just to put a satellite from Earth, we are given an escape velocity to that satellite because it doesn't come back. It does not come back because we are giving escape velocity, that is 11.2 kilometer per hour. For what? For what? If we are not given escape velocity, it will return back and hit on the center of the Earth. It's not happen. Why? We are giving escape velocity to that satellite, so it's a minimum speed for escaping from the gravitational field of Earth. Okay, escape velocity is the minimum speed with which a body can be projected from the surface of planet so that permanently overcome, not temporary, permanently to overcome the gravitational field of the planet. Permanently overcome gravitational field of the planet. What is this equation? Kinetic energy half mv square, potential energy minus gmm by r. So escape velocity equation is root 2 gr. Escape velocity equation is root 2 gr. Please listen. Escape velocity equation is root 2 gr. Just study this equation. Also, another equation root 2 gm by r. Escape velocity equal to root 2 gm by r. What it means? Gm is gr square. We all know that Gm is gr square because G equal to Gm by r square. Gm equal to gr square. Put that value of Gm here. So V equal to root 2 into gr square by r. R and r square get cancelled. So escape velocity equal to root 2 gr. So final equation is escape velocity is root 2 gr. If a satellite or any object having escape velocity, it will escape from the gravitational field of planet. That's it. It will escape from the gravitational field of planet. That is example or equation for escape velocity. Just notice that escape velocity equation is root 2 gr. That's all. Okay. Next, Kepler's law of planetary motion. This is the last part in this chapter. Last entrance topic in this chapter. Kepler's law of gravitational motion. We are already proved that t square, time period square, is directly proportional to cube of radius of the path. Consider this is the sun and this is the planet. Planet revolving around the sun through an elliptical orbit. Planet revolving around the sun through an elliptical orbit. Just to see this graphical representation, at the nearest of the sun, it take 1 month travel for this distance, but far away it take 1 month for this travel. That means the area subs are equal. Area subs are equal. We are already told, studied in board exam section. What means area is same? For increasing area, here it moves faster, but here it moves slower because there are so many area. Here area is lesser because it's just close to the sun, so it moves faster. Kepler's law of planetary motion. First is called a law of orbit. I'm already told that every planet revolving around the sun through an elliptical orbit. That is called a law of orbit. Second law is called law of area. I'm already told that area subs at different place, but equal times are equal. Equal times subting area are equal. Third law is called t square proportional to r cube. I'm already says that time period square is proportional to r cube. First one is law of orbit. The planet revolve around the sun in an elliptical orbit. It's very clear. This law is known as law of orbit. Very simple law. But the second one, it's very, very, very important. Kepler's law of planetary motion. The Kepler's law of planetary motion, the second one. Consider a radius vector from the sun to earth. This is earth. This is the radius vector. Suppose if a planet travels some distance in a finite time. Yes, planet travels some distance in a finite time. This is the area vector A1. In the finite time, it traces the area A1 with respect to the sun. Okay. In a finite time t, it traces area A1. In the next time, it traces A2. but the time are equal. The next time it cover area A2. The times are equal, then area must be equal. What it means area must be equal? Area equal means, listen, from P3 to P4, P3 to P4, area 2, P1 to P2, area 1, but time taken are equal. Here T, here is also T. Then area must be equal. There is simple confusions. Why areas are equal? Because here it moves little faster, here it moves little slower, so areas are equal. But time takens are equal. At equal time takens, the areas are equal. That is law of area. That is law of area. Please just listen. Just listen. Third one, law of planetary motion. That is time period square is directly proportional to r cube. Ratio type questions are erases from this part. What is time period? Time taken for a revolution. What is radius? This is the radius r. Radius of ellipse. Ellipse is a mathematical shape. Okay. What is the radius of ellipse? That is r. Then t square proportional to r cube, or t square by r cube proportional to a constant. It's very clear. That is law of planetary motion. Ready? These are the important topic in Kepler's law. Just understand, at nearest or closest to the sun, planet moves faster. At far away from the sun, it moves slower in order to equal area, in order to travel or swept equal area. So equal area covered in equal interval of time, that is aerial velocity vector, that is called law of area. Ready? So gravitational content part is over. We have to discuss 20 questions from this chapter. Okay. Next, we are discussing 20 questions. You will have material. I can solve the question. So please read question number 1. Okay. Read question number 1. And I am writing the answer. You can see that answers in this slide. Okay. Then first one, question number 1. I am taking pen. Oh, just a minute. Pen tool is not working. Okay. Number 1, question number 1. What is question number 1? You can also read. If the distance between two masses is doubled, there is a mass m1 and a mass m2, and distance between them is r. Then their distance between is doubled, it becomes 2r. What happened to the force? That is the question. Gravitational attraction. F is equal to g m1 m2 by r square. F dash is equal to g, mass does not change, so g m1 m2 by r square is not. Here 2r the whole square is get, because here is 2r. Second one, f dash. That means g m1 m2 divided by 4r square. G m1 m2 by r square is f by 4. That means f dash is equal to f by 4. Okay, f dash is equal to f by 4. Answer is option C, cat, is reduced to a quarter. Question number 2. The dimensional formula for gravitational constant is F is equal to G m1 m2 by r square. What is G? We have already discussed it in content session. Fr square by m1 m2. So Fr square means ml t raised to minus 2 force. R square is L square by m1 m2 means m square. M square get here, then m raised to minus 1. L square and L is L cube, then t raised to minus 2. Then which is the answer? Answer is m raised to minus 1, L cube, t raised to minus 2. T raised to minus 2. Answer is again option C, cat. Okay. Next question, question number 3. You can read the question. Question number 3. If the force of gravity disappears suddenly, then there are D option. Mass and weight of body remain unchanged. Never. Option A is wrong. Mass becomes 0 but weight remain unchanged. Never, never. mass and weight of the body become zero? No, because gravity is disappear. Weight becomes zero, but mass remain unchanged. Yes, answer is D. If gravity disappear, weight is not there because gravity is G. W equal to mg. G is zero, weight is zero, but mass is a constant quantity. There is no change for mass. It's very simple question. And next one, question number 4. Question number 4. Intensity of gravitational force inside a hollow spherical shell is very simple. Answer is option A, apple. I'm already discussed it. Inside there is no mass. There is no content. Okay. Next question, question number 5. We can read the question. There are two satellites. We have to solve the question like ratio of velocities of satellite, that is orbital velocity. Orbital velocity equal to root gm by r plus h. Gm by r plus h. Okay. But here this is mass of planet. If this is V1 for first satellite, V2 for second satellite. Okay. Sorry, question number 5. V1 for root gm by r plus h1. Next one, V2 equal to root gm by r plus h2. Gm and gm root all are same. So we have to find out the ratio V1 by V2. Gm get cancelled. What will we get? Root of r plus h2 divided by r plus h1. Ready? First one, root of 6,400 kilometer plus. What is second height? Second height. Listen carefully. Second height is 25600 divided by 6,400 r plus h1. What is h1? 1,600. So calculate this. We get 1 by 2. Answer is 1 is to 2. So it's very simple. Sorry. 2 is to 1. 2 by 1. Answer is get 2 by 1. This is multiple of this. Okay. So answer is get 2 is to 1. Question number 6. Write the question. Read the question. Mass of Earth is 9 times that of Mars. Mass of Earth is 9 times that of Mars. Radius of Earth is twice that of Mars. Escape velocity of the Mars is. Escape velocity of the Mars. We know that escape velocity of Earth 11.2 kilometer per hour. Okay. 11.2 kilometer per hour. The escape velocity of Earth is 12. In question it is given 12 kilometer per second. Sorry, 12 kilometer per second, not hour. 12 kilometer per second. V equal to root 2 gm by r. Okay, root 2 gm by r. This is V1 for Earth. For V2, it is also root 2g mass of Mars. This is mass of Earth divided by radius of Earth. Sorry, radius of Mars. This is radius of Earth. So from given quantity 2g into what is m? Mass of Mars. 2 into mass of Earth divided by what is radius of Mars? 9 into mass of Earth. Mass of Earth into 9 is mass of Mars. Then radius of Mars. What is radius of Mars? 2 into radius of Earth. This 2 get cancelled. Sorry, not cancelling. Just an idea. 2gme by re is 12. So root of 2gme by re is 12. So I written 12. Then what's the remaining? 12 into 9 by 2. That is the concept. 12 into 9 by 2. That means answer is given 12 into 9 by 2. That is calculating. We get to 4 root 2. 4 root 2 kilometer per second. Okay. Escape velocity at Earth is 11.2 actually, but here 12 is given 12 kilometer per second, but at Mars it is 4 root 2 kilometer per second. That is the concept. Okay. Next question number 7. In question number 7, the values are given. Mass of Mars is 1 by 9 of mass of Earth. And radius of Mars is 1 by 2 of radius of Earth. And a body weight 5.4 kilogram weight on 5.4 kilogram weight on surface of Earth. Then calculate the weight in the surface of Mars. W equal to mg. Okay, W equal to mg. It's clear, but what is this g? Mass is 5.4 kilogram weight. How can I calculate that? 1 kilogram weight is equal to 9.8 Newton. Okay, 1 kilogram weight equal to 9.8 Newton. So at the surface of Earth, weight equal to 5.4 into 9.8. Okay, 5.4 into 9.8. This much Newton. But actually, what is weight? Mg. Mg equal to 5.4 into 9.8. G is also 9.8. G and G are cancelled. Mass is 5.4. So weight at Mars, then we can use also 5.4. So no change for mass. Mass is always 5.4. Then what is G? G equal to Gm divided by R square at Earth. G at Mars is equal to G into M by 9 by R by 2. Okay. M by 9 by R by 2, the whole square. Listen, here we get 4 by 9 into Gm by R square. Clear? 4 by 9 into Gm by R square. Listen, this Gm by R square is acceleration due to gravity, that is 9.8 or 10, approximately 10. 4 into 10, that is 40 by 9 is here, 40 by 9. That is the G at surface of Mars. That is substituted here, 40 divided by 9. Calculate this much. This 0 is 10. 10 into 5.4, that is 54 into 4 by 9. While calculating, we get to 2.4. That is the answer. 2.4 is all. You can read the question. If Earth is okay. Question number 8. If the Earth is 1/4 of the present distance from the Sun, the duration of the year will be changed to duration of year. T1 by T2, the whole square is equal to or proportional to R1 by R2, R1 by R2, the whole cube. T1 by T2 equal to R1 by R2 whole raised to 3 by 2. In question, it is given that R2 is equal to R1 by 4. 1/4 of the present distance. That means R2 equal to R1 by 4. Listen, T1 by T2 equal to R1 by 4. R1 by R1 by 4, the whole raised to 3 by 2. That is T1 by T2 equal to 4. R1 get cancelled. This 4 gets numerator. 4 raised to 3 by 2. What is 4 raised to 3 by 2? First do 1 by 2. 4 raised to 1 by 2 means 2. That to 2 cube, that is 8. T1 by T2 equal to 8. What is T2? T1 by 8. So which one is the option? 1 by 8. Okay. T2 is 1 by 8 of T1. That is in our material, option is option D, dog. Option D, dog. Clear? Next we have to move question number 9. Question number 9. What is question number 9? You can read the question. You can read the question. All bodies larger of small fall with thee. All bodies larger of small fall with thee. Same force? No. Same velocity? No. Yes, same acceleration. All bodies larger of small fall with the same acceleration. That is the option C, cat. Why same force? We don't know. Falling acceleration is always G. That is same always. Force is never, maybe not same, but and also velocity is maybe not same. Momentum is maybe not same, but acceleration is always acceleration due to gravity. Question number 10. It's very simple question because I already explained that this is an elliptical path and the sun is located at one focus of ellipse. Earth is revolving. Here Earth is revolving slowly near the sun. Here Earth is revolving fastly. So which one is the point? The kinetic energy will be greatest. That is the question. Here planet is Mercury. Kinetic energy will be greatest. Where will be the maximum velocity? There will be the maximum kinetic energy, because kinetic energy equal to half mv square. Here velocity is maximum. So at point C, this is point C, there will be velocity maximum velocity. So no doubt at all. Velocity maximum means kinetic energy maximum at point C. At any point within the interior of the Earth, the acceleration due to gravity varies with r. Distance between the center of Earth and the point, that is r. Acceleration due to gravity varied. We all know that equation, that is acceleration due to gravity variation with the depth, g into 1 minus d by r. That is the equation. Okay. Then distance between the center of Earth and the point will be, what it means? Answer is, we all know g is equal to gm by r square, and g dash or gd, acceleration due to gravity with depth, equal to gm by r minus d the whole square. Okay. There is slight difference in mass also. Yes, because when moving towards depth, we are only consider that part mass of that part only. So m is changes, radius is changes. So it is proportional to 1 by r square. What is r here? R minus d. That is the r here. Distance is r minus d. So that is r. So answer is g proportional to 1 by r square. There is an option yes, dog. Answer is dog. Okay. In question number 13, one goes from the center of Earth to a distance 2/3 of radius of Earth. That is, he is moving 2 by 3 r. Okay. Where will be the acceleration due to gravity be greatest? Where will be the acceleration due to gravity is higher? That is the question. Option A is not answer, because at the center of Earth acceleration due to gravity is 0. At the height half the radius of Earth. What it means? At a height half the radius of Earth. That means this is Earth and this is r. Then he is moving r by 2. Find out the acceleration due to gravity value at this place. That is option B. At a depth 1/3 of the radius of Earth. That means at a depth r by 3 here. At a depth r by 3. That is here. Okay. And last one, at a height equal to the radius of Earth. That is a height equal to r. That is this point. The answer is option C. It's very clear, because the center and distance between the center and the body placing point, that is small letter r. Okay. This gm by r square. This is radius. When this radius decreases, then the value of g increases. When radius decreases towards depth, moving towards depth, that is why answer is option C. Question number 13, answer is option C. Question number 14 is a very simple question. Law of conservation of angular momentum. Law of conservation of angular momentum will give from Kepler's first law? No, it's law of orbit. Kepler's second law. Yeah, it is the law of angular momentum, because that law says about aerial velocity. Aerial velocity. A law says about velocity. That means it says about momentum, because momentum is mass into velocity, linear momentum. Angular momentum is mass into angular velocity. Anyway, it says about velocity. Area subs are equal in equal interval of time. That is second law. So answer is second law of Kepler. Answer is second law of Kepler. Okay. Question number answer is second law of Kepler. Okay. 15. Question number 15. The force of gravitation between two bodies of mass 1 kilogram each separated by a distance 1 meter in vacuum. So F is equal to G into M1 M2 by R square. What is M1 M2? 1 into 1. What is R square? 1 meter. So this whole term is 1. Then F is equal to G. What is G? 6.67 into 10 raised to minus 11. That is the answer. So in options Option C is the answer. Question number 16. The value of G at moon is 1/6 of the Earth. A balloon filled with hydrogen will. Listen, acceleration due to gravity at moon is 1/6 of acceleration due to gravity at Earth. Okay. Then weight W at moon is also 1/6 of weight at Earth. Weight at Earth is 6 times greater than moon. That means in a hydrogen balloon jumps and it moves a distance h. Consider it moves a distance h because it has a weight mg at surface of Earth, but it moves greater than greater than that because at moon, because its acceleration due to gravity is g/6, so it has no weight. It has no weight. No weight means weight lesser than at Earth. So answer is option C, cat. Answer is 16th question. Answer is option C, cat. Rise with acceleration g/6 on the moon. Yeah, rise with an acceleration g/6 on the moon because there is g/6 times lesser than that of acceleration due to gravity at Earth. Question number 19 is a very, very important question. 19 is not. Question number 17. Look at that question. Acceleration due to gravity on a planet is 1.96. If it is safe to jump from a height 3 meters on the Earth, the corresponding height of the planet will be. In Earth, we can jump 3 meters. Okay, then what is its velocity? V square minus U square equal to 2gh. Okay, that is equation. Initial velocity is there. Final velocity, the acceleration due to gravity, the safe to jump from a height of 3 meters on the ground. From a height of 3 meters. So initial velocity is 0 because jumping is starting from a height. Final velocity is maximum. V square is equal to 2 into 9.8 into h. What is h? 3 meter height. 2 into 3, 6. 6 into 9.8. V is equal to, by calculation, V is equal to 7.7. Okay, V equal to 7.7. In that case of planet, V square minus U square is equal to 2gh. We have to find out this h. We know the V because same velocity of that of Earth. That is the question. 7.7. Put the value. U square is also 0 because jumping is started from a height h. So a dropping body, jumping body, all have initial velocity 0. V square 7.7 the whole square. 7.7 the whole square. Into 2 into, sorry, equal to 2 into, what is G? G is a very, very familiar value. G G is given question 1.96 into H. We have to calculate H. How we can calculate H? 7.7 the whole square divided by 2 into 1.96. By calculating, we get 15. 15. So 15 is the answer. Very simple. 15 is the answer. Dog. D is the answer. Question number 17 is also done. In next question number 18. Question number 18. Read the question. In question number 18, they are given southern hemisphere of Earth is upside, but people living there do not fall off the Earth because, see, read that option. Earth attracts everybody towards its center, so we are not falling. Yes, we are not falling to sky. Yeah. So answer is C. Answer is option C, 18. Question number 19. A spaceship is moving through the Earth atmosphere is likely to catch fire. This is due to viscosity, that is a resistance, a resistive force by air. Okay. Question number 19 is okay. Question number 20. What is question number 20? The weight of the body at the surface of Earth is W. At the depth half to the center of the Earth, it will be assumed to be. When it is half, G is half, G by 2. their acceleration due to gravity is g by 2 because W equal to mg. When weight become half, not mass is changing, g is changing. G dash is g by 2. That is the concept. G dash is g by 2 is at there. So listen, dear students. At the depth halfway to the center of the earth. Halfway means g dash is g by 2. Then weight is g by 2. Answer is very clear. Boy. 19th answer is boy. Sorry, 20 answer is boy. There is another two questions. I think that questions you have. 21. Gravitational force between two bodies is option A, attractive. Attractive at all places. Attractive at all places. Newton law of gravitation is universal because it is always attractive. It is not affected by the medium. Act on all masses at any distance. Yes, yes. Both are correct. Sorry, all are correct. Dog is the answer. All of the above is correct. So these are the discussions. Question number 22 answer is dog. I think that 21, 22 questions you have. Otherwise, you must study that 20 questions for our discussion section. Okay, clear. That is gravitation is over.